This situation is asking us to give a mathematical equation that could be used to solve a problem, and that involves Pythagorean theorem. My yard is a rectangle with sides of 7 meters and 5 meters. If I run my clothesline across the yard diagonally, what equation could be used to find the length of the clothesline? On the surface, this is a fairly straightforward Pythagorean theorem situation. The 7 meter and 5 meter sides of the yard have to be forming a right angle because the yard is a rectangle, and they will form a right triangle with the clothesline, which is the hypotenuse of that triangle. So I could use Pythagorean theorem and I could find the length of the clothesline. But I have to slow down and be careful, because this time I am not being asked to find the length of the clothesline. I am being asked to give an equation that could be used to find the length of the clothesline. I have to put together a mathematical expression which is equal to my unknown, which is the length of the clothesline. For a simpler example, if I have $40 in my pocket and my friend has $50 in his pocket, we could be asked to give a mathematical equation that could be used to find the total amount of money we have together. If we go too quickly, we could say $40 plus $50 is $90, and we could give $90 as our answer. It is a correct answer to the situation, but we were asked to give a mathematical expression, and that is not a mathematical expression. What I could do instead to answer that question correctly is I could say, let x equal total money that we have together, and $40 plus $50 must equal that total. This is a mathematical equation where my unknown is being made equal to an expression that, if simplified, would give me the exact value that I'm looking for, the total amount of money that my friend and I have in our pockets. This Pythagorean theorem situation is similar. I am not being asked to find the answer to this situation. I am being asked to give a mathematical expression which is made equal to a variable, and that variable should represent the length of the clothesline. Let's move on ahead though and solve the situation using the Pythagorean theorem so that we can see what the answer would look like. H squared, well, I don't know the hypotenuse of the triangle yet, will be equal to, I can make 7 and 5 my A and my B, and h squared is equal to 7 squared plus 5 squared. 7 squared is 49, and 5 squared is 25. So h squared is going to be equal to the total of 49 plus 25, which is 74. I'm not finished yet, because I'm not being asked what h squared or the hypotenuse squared is equal to. I'm being asked what h is equal to, what the hypotenuse or the length of the clothesline is. So if h squared is equal to 74, h will be equal to the square root of 74, which is 8.6 if I round to the nearest tenth, and the unit is meters. But the student here is not being asked to find the length of the clothesline. The student is being asked to find an equation that could be used to find the length of a clothesline without simplifying, without calculating. The closest thing I have written down yet that would answer the question is this here. H squared is equal to 7 squared plus 5 squared. I have not simplified these numbers. I have just merely plugged them into the equation, and if I were to continue on, I would get the right answer. The only problem with this as a final answer, though, is I am being asked for the equation that could be used to find the length of the clothesline, h, hypotenuse in this case. I am not being asked to find an expression that would find h squared. So I have to find a way to make this equation have an equal to h in it and not h squared. What I have to do then is, if h squared is equal to this mess, then h must be equal to the square root of that mess. So if I write h equals square root and put 7 squared plus 5 squared inside the square root, I am not simplifying, I am not calculating with the numbers, but I have done some math to isolate my h. If I were to solve this expression, I would find the length of the clothesline. So this is the right answer.